Hey guys, welcome back to a new video. So in this video we will start to set up everything we need for our dependency injection, and initially I wanted to use Dagger-Android for dependency injection for this running app here, but recently Google announced the new Dagger-Hilt library, which is very popular right now because it is much easier. So I tried it out and converted my running app from the old Dagger to Dagger-Hilt, and it just got 160 lines of code less. So initially this project had about 1,800 lines of code, but after I switched from the old Dagger library to Dagger-Hilt, it now has about 1,600 or a little bit more, but that's about a 10% decrease in lines of code just by switching a library. So I just decided to use this Dagger-Hilt library in this project, which really solves a lot of problems much easier than the old Dagger library. Well, it's still an alpha, but I didn't encounter any major issues with that, so I will just go on with it and everything will work fine. So let's first start to add the Dagger-Hilt dependencies to our build.gradle app file. So let's open that. And yes, scroll down to our dependencies block here. And below the Dagger-Android block, I will just paste the Dagger-Hilt dependencies. So those are the dependencies for Dagger-Hilt, and that is an additional dependency for activity KTX for view models. As you can see, that will just make it very easy later on to inject stuff into view models. And as usual, you can get those dependencies from this video's description. There you can find a link to my GitHub repository for this project, and then you can just copy and paste those. So you don't need to write them off, of course. Then we will scroll up and we need to apply another plugin here, which I will also paste, that Dagger-Hilt plugin. And we also need to add another class path in our build.gradle project file. So let's open that. As you can see, we already have that class path for navigation components, but we will also need to add this Dagger-Hilt class path here. So that plugin will actually be recognized that we added here in our build.gradle app file. But if you've done that, we can simply click on sync now and Gradle will do its job. So when using Dagger-Hilt, the first thing we need to do in every app we use it is to actually tell our app that it should use Dagger-Hilt as dependency injection tool. And for that, we need to create an application class. Let's go to our root package and create a new Kotlin class here. Call it base application, select class here, and this will inherit from application. And the only thing we need to do to mark this application as injectable with Dagger-Hilt is we need to add the annotation add Hilt Android app. And somehow it doesn't show suggestions here, but you can see we can import that annotation. Let's press Alt plus Enter to do that. And now it recognizes that annotation. And as I said, Dagger is compile time injected, so that means when we launch our app, it is already clear which dependencies will be injected into which classes. So how can it actually happen that we just need to annotate this application class to mark our application as injectable? And the answer for that is that the true power of Dagger is in the generated code, because we only see this annotation here, but behind the scenes Dagger will generate a whole bunch of code files, so Java files in this case, that handle the actual injection. And if we rebuild our project, then we will generate those code files. So let's do that. Go to build and click on rebuild project. And after the rebuild is finished, we can go to our project hierarchy and open that Java generated folder. You can see we have two COM folders here. I think that is the correct one. Yes, you can see we have some classes that are generated by Dagger-Hilt for us. For example, that Dagger base application, Hilt components, Hilt base application, and we can open those classes. You can see all that is code that the Dagger-Hilt library generated for us. So of course you shouldn't touch that code or change it, but I think you should be aware of the fact that Dagger actually generates those code files behind the scenes for us, and that those code files are the actual reason why that dependency injection works here. And just by annotating our base application with add Hilt Android app, we just tell Dagger that this is our application class, and Dagger needs to know that to actually generate those code files for us. But of course, that is not everything we need to do for injecting stuff. Still, with Dagger-Hilt, it's much less that we need to set up here to actually be able to inject dependencies into our classes. But what we also need is called a module. So let's say we want to be able to inject our running database into our repository that we don't have yet, but later on we want to do that. And if we want to inject that running database, then Dagger of course needs to know how to create that. So it somehow needs a manual by us how to create a running database so it can inject that into our repository later on. And because only we know how to create that running database instance, we need to tell that Dagger and give Dagger kind of that manual so Dagger also knows how to create it. And these manuals are put into so-called module files or module classes. And for that, I want to create a new package in our root package called DI for dependency injection. And inside of this DI package, I will create a new Kotlin file or class, and I will select object here because in Dagger-Hilt we use objects, so singletons for those modules most of the time. And this module will be called AppModule. And what I call the manual here is actually nothing different than a function, because in that function we will simply create that object that we want to be able to inject and then simply return it. And those functions will be put into those module classes here. First of all, what we need to do with every module we have is we need to annotate it with AppModule. But this single annotation for this module class is not enough. Instead, we also need to add the add install in annotation. And in the parentheses here, we need to put application component : class. So what does that actually mean, that installed in and application component here? In the old Dagger, we actually had to create those components by ourselves, and that really was a lot of complicated code, but in the new Dagger-Hilt, we don't need to do that anymore, because those components are used to determine when the objects inside of our app module are created and when they are destroyed. So what this means in particular here is we tell Android Studio or our app that it should install this module inside of this application component class. So that means, because we use application component here, if we take a look into our base application class here, it would mean that in the onCreate function of our base application class, all of our dependencies that we declare in our app module, so all of our manuals, all of our objects that we want to be able to inject, those will be created in the onCreate function of our application. So that means they will exist during the whole lifetime of our app. And when our app is destroyed again, so when the user quits that app, those dependencies are destroyed too. So you probably know the behavior of a singleton, because that is exactly what this will do here. We of course don't need to override these functions by ourselves because Dagger will handle that for us. But we don't only have that application component here, we also have, for example, the activity component. That would mean that this app module will be installed into the activity component, which means that the dependencies inside of this app module will only be available during the lifetime of a particular activity. So that means when the activity is destroyed, then also those dependencies inside of that app module will be destroyed. So they won't live until the application dies. Instead, they will only live as long as the activity lives. And for each major Android component, we have such a component class by Dagger. So we also have a service component, for example. We also have a fragment component and so on. But for this module here, I will use that application component again, because in this module we will declare our database dependencies. And we of course want this database instance to be a singleton. We only want to have a single instance of that reference because we don't need multiple instances of that to access our database. A single instance is enough. But let's actually define such a manual, such a function in which we will create our running database, so you actually see how that works. Let's define that as a function, and I will call it provide running database. So that function will provide a running database for a class that will use that running database. And that will be equal to room.databaseBuilder. And here you can see for that database builder, we need the context. But since we're inside of this module class here, we don't have access to that context by default. But what we can do here is we can go into the parameters of that function and create that context so we can use it in that room database builder here. Let's actually call that app, which is a context. And of course, just by writing app, which is a context, Dagger doesn't know from where it should get that context. The solution to that problem is that we annotate this with application context. So what this will do is it will just insert the application context for this app variable or this app object here. And in the old Dagger, this really was a lot more code than just annotating this context object here with application context. So that is also something that is now much easier with that new Dagger-Hilt library. But since we now annotated this context with application context, we can use that app in our room database builder. So you can see we need to pass that context here, and we can simply pass our app. And Dagger will actually insert that context here behind the scenes for us, so we don't need to call that function by ourselves. And as a second parameter here, we need to provide the class of our database, which is running database ;class.java. And as a third parameter, we need to provide a name for our database, which I will create in a constants file, which I will create right after I write running database name. Let's go to our root package, create a new package here called other for all kinds of classes that don't belong into any other package, but just for organization, I created a new package for that. And inside of this other package, we will create a new Kotlin file or class. I will select object here, since that's a singleton. We only have constants in that file. And I will call that class constants. And in this object, I will just have a const val running database name. And I will call this running_db. Then we can go into our app module. And here we need to import that constant now. And after that, we are good to go. And to actually create the instance now, we also need to call .build afterwards. But right now, this is just a function that doesn't do anything, because we also need to annotate that function and tell Dagger that this function should actually provide something for us. And the annotation for that is actually the same. So we write @provides to tell Dagger that the result of that function can be used to create other dependencies and can also be used to be injected into our classes. But what is now very important is that if we leave this function like that, then that means whenever we want to inject that database into somewhere, into some classes of us, then it will create a new instance of that database each time. So that means if we have two places in our app in which we want to inject that database, then each place will get its own instance, but that is of course not what we want here, because we want to have an application-wide singleton instance of that database. And the solution to that problem is we need to attach a scope to this function. And such a scope is, for example, the singleton scope. So we annotate this with @singleton. So that will just mean now that each class in our app that needs that running database will get the same instance and not multiple instances. And generally, we don't really need access to that database class. Instead, we need access to its DAO object, because with a DAO object, we can access all those database functions that we need in our app. And for that reason, I will create another function here that will actually provide our DAO object. And to actually show you how Dagger will manage that for us, because now it has kind of that manual how to create a running database, and it needs that manual to be able to create that DAO object for us, because it can only create a DAO if it knows how to create a running database. And for that, I will also annotate the new function with @singleton and also @provides. And I will actually make a little bit of space here. And that new function will be called provide run DAO. And as a parameter to this function, we now need to pass our running database. So we pass db, which is of type running database. And this will provide our DAO by writing db.getRunDAO. So just the DAO object of our running database. And now the cool thing about Dagger is, you can see we provided that running database here as a parameter, and Dagger will automatically recognize how it can construct that db object here, because we also gave Dagger that manual here how to create that running database. So we don't need to pass that by ourselves. Instead, Dagger will manage that for us. And in general, Dagger will call all those functions by itself. So we only define those functions here, but we don't actually call them by ourselves. That will instead be done in the classes that Dagger generates for us. And what we shouldn't forget now is to actually mark our class, our application class, as the main application class of our app. To do that, we need to go into our manifest file And in the application tag, we simply specify a name property here and pass our base application. And now we actually did everything we need to do to be able to inject our running database or our runDAO into some classes of us. And to actually test that, let's go into our main activity. I just want to test if everything is working and inject our runDAO here. Of course, this is not the place where you should do that. Just to show you that everything is working, I will do it in this main activity, but in the next video we will actually do that in the repository we will create then. So if you watched my previous video where I explained Dagger in general, then you already saw that add inject annotation I showed you there. So what we want to do here is we want to create a late init var called runDAO, which is of type runDAO. And the only thing we need to do to get that runDAO is to add the add inject annotation. So this annotation will tell Dagger now that we want to get that runDAO object from one of our modules. Then it will look in our module, in our app module, and it will see, okay, we have a function here that provides such a DAO object, and I can create such a DAO object with that DB reference, but I don't have that DB reference yet. So let's take a look how I can create that. Then it will see that provide running database function, and it will see that this actually provides that DB reference that is needed to create that DAO object. So Dagger has actually everything it needs to create our runDAO. So behind the scenes, it will actually inject that runDAO into our activity class here. And whenever we want to inject something in an Android component class with Dagger-Hilt, so for example an activity, a fragment, a service, or so on, then just writing add inject is not enough to do that. Instead, we also need to annotate this whole class with add Android entry point. And now that is really enough to be able to inject that runDAO into our main activity. And just to test that, I will add a simple log statement here. I know we have that logging library Timber actually, but I didn't set that up yet. I will do that in the next video. So just write log d. I will import a log here. Give it a tag of runDAO, and I will just print runDAO colon, and here I will use that runDAO.hashcode. Of course, that won't tell us anything important here, but if it prints something, that just means that our runDAO is actually an object and it didn't crash, so that means our injection was successful. So let's actually run our app, and hopefully everything is working. Take a look in our logcat and search for runDAO, and you can see here's our log. That is the hash code of our runDAO. So that means our runDAO was instantiated and successfully injected into our main activity. So you can see we have a late init var here, and we didn't instantiate that by ourselves, but Dagger did it for us. We can still access that instance, so everything is working perfectly fine. So I know that was a lot of new stuff, and because of that I just want to go through everything we did here just as a quick little recap. Let's start in our base application class. We annotated this class first with add-hilt Android app to tell our app that we want to inject dependencies using Dagger-Hilt. Then we created our AppModule, which we'll actually have here, in which we will create all of our manuals, our functions that provide the dependencies for us. So we annotated that module with AppModule just to tell Dagger that this is a module we will use here because it somehow needs to find our functions inside of our modules. And we also annotated this module with add-install-in. So we told Dagger that we want to install this module in our application component class, which means that the dependencies, the objects we create in this module, live as long as the application does. So they will be created when our application is created, and they will be destroyed when our application is destroyed. And maybe it confused you a little bit what the difference between that application component is and that singleton here, because that singleton is a scope and that application component is not really a scope. The difference is that that application component determines when those dependencies will be created and when those dependencies will be destroyed. And that singleton means that only a single instance of those dependencies will be created at a single time. So theoretically, we could have several instances of our running database that all live inside of that application lifetime, but each of those is its single instance. But we don't want that, of course, so we attach that singleton scope, which will mean we only have a single instance during the whole application lifetime. So yeah, then we have those provide functions here, which we needed to annotate with add provides, and those functions are the manuals I talked about. those just determine how our objects that we want to inject are actually created. And when a provides function needs another object that was already created, then we can simply pass that object as a parameter to that function. And if we take a look in our main activity, we needed to annotate that with @Android entry point, because that is an Android component class, an activity. Then we always need to do that. And we want to inject the one DAO, so we add the @inject annotation, and Dagger will automatically find the right dependency with the type run DAO and inject it here. So I really hope this was somehow useful for you and understandable. If so, please let me know that below. That would make me really happy. And really don't mind if you have any questions about Dagger-Hilt, just ask them below. I will take my time to go through them, and if I can, answer them. This can really be confusing for beginners here, but trust me, this is so much easier than the old Dagger library. So just be happy that Dagger-Hilt was made and that it was made right on time, so I can actually use it in this tutorial here. Have a good day, see you in the next video. Bye bye.